We're going to look in the notes in section 4 for some vocab. First one we're starting out with is the parts to whole theorem. And what that's saying is that whenever you have two or more parts, you can put them together to form the whole. So for example, if you had the angle PQR and the adjacent angle QRS, you would form angle PQS. And so it seems pretty straightforward. It's basically saying that this part here and this part here add up to the whole thing. The same applies with the line segment. If you have this segment here and this segment here, and you add them together, it's going to form the entire segment, AB. So AC plus CB equals AB. Now if we're going to write that out, we could say over here we have angle PQR plus angle RQS, and that is equal to angle PQS. Same idea down here. We have switch colors. We have segment AC plus segment CB, and together AC and CB is going to form AB. That's called parts to whole. And if you wanted to write out a definition, it's taking two or more parts and putting them together to equal the entire whole thing. Next one is a bisector. And a bisector cuts things in half. So you might even want to just write cuts in half. And it can cut a few different things in half. It can cut either an angle in half or a segment in half. So if you had an angle bisector, let's say this right here is an angle bisector, it would cut this larger angle here, just trace this out here, this larger angle into two equal parts. So we would have this angle here, and we would have this angle here, and they would be equal in measure to each other. So a bisector would cut that angle directly in half. You could also have a bisector that cuts a line segment in half, like we would have over here. So if you said that your bisector was CD and it was cutting or bisecting side AB, we would be left with two equal chunks here. So again, this angle bisector, it bisects the angle, means it cuts it in half. Over here we have a bisector that cuts the segment in half. Next one is a midpoint. Midpoint is pretty straightforward. It is halfway between the endpoints. So halfway between endpoints. And it is a point itself, so it is a point halfway between the endpoints. And in this picture you can see C is in the middle of A and B, so C would be the midpoint. Continuing on here, we're going to figure out how to calculate the midpoint. The midpoint is calculated by finding the average of the x-coordinates and the average of the y-coordinates. Now, if I have -2 and 4, I could actually just count. Go in one over here, go in one here, in one more, in one more, in one more, in one more, and so it seems like this here is going to be my midpoint, and that's doing it graphically, just trying to find the middle of the line segment. I can also do it analytically, where I take my x's first. If I take the 4 and the -2, and I want to find the average of those two numbers, whenever you find the average of two numbers, you add them together, so 4 plus -2, and then you divide by however many numbers you have. So in this case I have two numbers, so I divide by 2. 4 plus -2 is 2, and then I'm dividing by 2, and that's going to equal 1. So that's my x-coordinate, because I took the average of my two x values. And you can see here that on my graphical view, having x equal 1 actually makes perfect sense. Now let's get my y coordinates, so my height. I've got a y value of 1 on one end and a y value of 3. Now looking at those two numbers, it's pretty clear the average is going to be 2, because 2 is going to be right in the middle of them, but let's just write it out for practice. So we have 1 and 3, and we're finding the average of them. So we add them together and divide by the number of numbers we have, which is 2. 3 plus 1 is 4. We're still dividing by 2, and then our y value is 2. So the midpoint, if you were to write it out properly, is going to be 1, 2, x, y, x value, y value, 1, 2. And then finally we're going to calculate distance. Now there is something called the distance formula. It's a big long formula, and it's probably not worth the time to memorize it because there's actually a much simpler way to think about it. If you think of the Pythagorean theorem, a squared plus b squared equals c squared, anytime you have a line segment on a coordinate plane like this, you can turn it into a right triangle. And you can see here, if I trace this out, and I go straight across and straight up and down, I'm going to form a right angle over here. And then this line segment that I'm finding the distance of is always going to be my hypotenuse. How do I find the height and the width of this triangle, however? To find the height, you just find the difference between your y values. So if we have a height of 3 over here and a height of 1 over here, the difference in those two is what I'm going to find by subtracting. 3 minus 1 is going to be 2. And you can see if I were to count boxes here, 1, 2. Going across, it's the same basic principle. I have a 4 here and a negative 2 over here. Well, how far are 4 and negative 2 apart? I would technically be subtracting 4 minus negative 2. Another way to think of it is to say 4 plus a positive 2, which is going to give me a 6. So 4 and negative 2 are 6 units apart. Now I have my triangle set up. So all I need to do is take 6 squared plus my 2 squared, and that's going to equal my c squared, or my distance squared. So 36 plus 4 equals c squared. Add those together and I have 40 equals c squared. Now I could choose to write this, my answer, as simply square root of 40 by taking square root of both sides. I could also pop that into my calculator and get a decimal approximation. It's going to be somewhere between 6 and 7. But I'm going to choose to just leave it in the radical form here, the square root of 40, and I could write that right over here. That is my distance.